So when you talk about error, no matter everything that we do, for us to be able to improve our neural network, for us to be able to improve our neural network, we need to deal with errors. We need to deal with errors. And when you talk about errors, when you talk about errors is basically the difference between our desired output. Is the difference between our desired output and the desired output provided by the training data and the actual output. That's error. So what I basically mean, I'm just trying to say that our network can predict something for us. Our network can predict something for us. And what he's trying to predict, there's always like a value or a value that the network is trying to target. And that targets what we are referring to as our true value. And what the network predicts is what we refer to as our actual output. Like our desired output minus our actual output will give us an error. And let's see if we can just deal with this error to help us improve our neural network. So you have to keep this one in your mind. E is equal to C minus O, like our error is equal to our true data minus our actual output. So you have to keep it in your mind. So now if we get the error, so if we get an error like this, how do we use that error to improve our network? If you have not been following this tutorial up to this point, it's very difficult for you to understand even this diagram here. It's very difficult for you to understand this diagram here. What this diagram is doing here is this is our network are using. You see the three nodes there. They are our network we have used, and they've given us an output. They have given us an output, and this output that they give us, there's an error attached to this output because that wasn't the true one we are looking for. Maybe like it wasn't able to target the true value. So there'll be an error. The error from this side, what can we do with this error? What can we do with this error? What you can do is that you can see that this node, the final output node here is just one. But that node is being connected to by two nodes. It's connected to by two nodes. You have one is here, and another one is here. Can you see my mouse moving?
Yes.
Here. So you can see this the output node is connected by this two nodes, the one and another two here. But we're having an error here. So what should we do with the error? What you can do, someone can say that, oh, since you have an error here, let's try and share the error among these ones and give half of the error to this node 2 here and give the other error to this node here. Ransford, okay, see, has been, okay, Ransford. What do you want to say?
Uh, your cursor is no more showing.
Is it showing?
Yes, yes, it's not showing.
Are you sure? So what I'm just trying to say, we got after the prediction, we get an error. And that error, what can we do with that error? Should we share the error among the nodes contributing to the output, or just give that error to just one output? And normally what we can do is this. Well, what we can do is we need to share that error. Say we have to distribute that output error that we had among the contributing nodes. So this example is the output came from this final node here, but this final node is just a standalone node here because that node is being connected by two other nodes here, like one and two. So if this node is getting an error, what we are just trying to do is I just want to take that error and just send it back to our first layer. They can just use it to update our node. So the error you have in here, you're just trying to send it back. So sending it back was node. Someone can just say it's equal among the nodes here, these two nodes. But normally, it is good to share it proportionally among the nodes. When I say proportionally, what I mean is that the one contributing more should get more of the error. The one contributing less should get less of the error. You can see the error here. This one is getting 3 over 4 of the error. And this one is getting 1 over 4 of the error. Because the weight link for this one is just 1. The weight link for this one is 3. You see? So that's what you mean by proportionality. You have to share the error among them proportionally. And yes, the same idea again, but this time you're just dealing with two outputs. The output is just coming from two nodes. The output is coming from two nodes here. And this is the nodes. It's the same idea. We are sharing it proportionally. You can see this is the output. This one given an output of O1. This one given an output of O2. And that was the error from this output, E1. And there's an error from this output, E2. So you can see that they are sharing the error here. It goes to this side and goes to this side. It just doesn't go to any node here. It only goes to the nodes that are contributing to the output for this error. You can see there's one comes to this one, this link here. But this link is contributing to the output for this node. And this link is also contributing out for this node. And the same idea is also applied here. So no matter the number of nodes you have in, the only thing you're supposed to do is just to find the link weight connecting to it and just share it among its proportionally. Okay. So if you have almost 10 nodes or 3 layers or 4 layers, you can still do the same idea for it. So then what what you can see is that for the first link weight to the first node, this will be the formula. What the formula is trying to tell is that when you check this output here, for us to be able to transfer this error to this node here, we have to share proportionally. And to share something proportionally, you have to take the value here, because you're dealing with the link weight. You have to take the value of the link weight here, then divide it by the total link weight. That's what we're connecting to that node. Example, you see this node here. You know how many link weights are connecting to that node? Let me take this node here. How many weights are connect? How many weights link are connecting to this node?
Two.
It's two. Is what the link one is W21, this weight link here, and the other one is W11, this weight link here. So to get the contribution of the error that will go to this weight link here, we have to find its proportional value. Proportional value is just W11 over W11 plus W21. That's what they're saying here. W1 over W1 over W1 plus W21, because the error because the error from this node here is being affected by, or it was contributed by these two links. That's why you can see the total output. The denominator here is just those two link weights. So that will be the portion for this value for this link weight here. The same thing for us finding portion for this link weight here. The same idea we're going to use. It's just become W21 over the total link weight that's connecting to it. W11, W21, W11, W21. And when you go to the next one too, when you go to the next node here, when you go to the next node, it's the same idea. You can see that the link weight is this one and this one. So the proportional value for the error for this one just become W12, I see W12 over W12 plus W22. So what we are just trying to do is that we just want the then say give us an out, will give us an error. And we just want to just send that error back to our first layer. Then can use it to update. So we're just trying to send it backwards. And when I send it backwards, how do we send it backwards? We send it backwards proportionally, meaning those contributing more get more of the error, and those contributing less will get less of the error. So you should understand how to just get the proportional value for weights, for link weights. An example, if I just tell you, you can see this the weight link here, W21. What weight is proportional error value? Now you want to just find its proportion as with respect to the error that will come to later. If I should ask you what weight is proportional to this fraction of the error, the only thing you have to do is just watch that link weight. Look at that link weight. Where is it going to? It's going to this node here. And this node, it's this node here. You can see which other links are connecting to it. The other link are connecting to it is just W11. So the proportional value for this W21 will just become W21 over W21 plus W11. Because this link weight is connecting to this node here, and this node is only two links, this and this. So you have to just use those two values just to find its proportion. I don't know if it's understandable to you guys.
It's okay here.
Is it?
I said
It's
I'm okay.
okay. But the rest of you guys, I don't know if David, Ernest, then Raman.
Yes,
I
please,
don't know
it's
if you
okay. It's okay
we
for
just
my
joined.
side too.
It's okay for message too.
Yes, please.
All right. So let's just continue and see what we can do about it. Let's continue. So you can see, since we don't have a direct error for our hidden layer node, we can recombine the errors coming from the output node into the hidden node. That is the error from the link weight. Do you understand what this one is trying to say? He's trying to say
Please
that
go back again.
he said,
Ah, okay, okay.
what this one is just trying to say is that see this thing here. You know this link weight will have an error. You know you have a proportional or have a portion of the error. But what will be the error in this node here? The whole node here. This link weight will give us an error. But what will be the error for this one? The error for this one will just be the recombine errors because you know this link weight coming backwards, they're all coming to this node here. So you take the error that this one is bringing, take the error that this one is bringing, add it together, and that'll be the error for this node here. That's basically what you're just trying to say here. So what I just doing, we call it backpropagation, error backpropagation. Just trying to propagate the error backwards. We're just trying to propagate the error backwards. So if I should just propagate the error backwards, if I want to also propagate this backwards to this node here, the only thing I have to do is just after I get the error here, you just have to divide it again among this one proportionally, this one and this one, and the proportion for this one and this one. Okay, this we have to divide it among this one and this one. Okay, then come and divide this one to this one and this one. So when you just watch this node, you can see that the link weight is just this one and this one. And we find the proportion for this one and this one, add it together, and that will give us the error for this node here. The error for this node in our first layer. One input layer. So it looks more like this one looks more like an abstract stuff, or it looks more like a diagram and mechanical stuff. But if you understand the course out here, you can just move ahead. So, so he said he said E hidden one. He's saying E hidden one. So this E hidden one, this E hidden one, and see the total error into this one, the error into the other node. You see what the error into that node is just some of the split errors on links W1 and W12. Because when you check the link, the proposed for the link W11 is just this one. W11 over W1, W11 over W1 plus W21 times the error, this output error. Then plus W12 over W12 plus W22 times the error here. But can anyone explain to me that the reason why the output here, this one is E output 1 and this one is E output 2, but they are not having the same out. It's wasn't the same error that we use for both of them. When you check this diagram, you can see that when you find the total error into the E hidden here, you can see we didn't when we're multiplying here, we didn't use one error for them. E output 1
Sorry,
and E output.
can you go back to the last page? So
So when
this for error alone.
you said
So this for getting the error.
no, we are transferring the error backwards. We are propagating the error backwards.
Oh, okay.
Yeah, we've got after the next is going to give us an error. We are trying to send the error backwards. So we use that error to update.
Oh, I'm not understanding.
We did feed forwarding. Feed forwarding, we tried to pass the signal from our input layer to our output layer
Okay.
last week. And then
Yeah, yeah, yeah.
after after the feed point is going to give us an output, and that output
Yes.
is more like a prediction of our desired output. It's trying to predict something for us, and that prediction
Okay.
that it making, that prediction it making, the prediction there might be an error in it, meaning it's not going to give us the correct one you're looking for. There will be an error in it, and that error, what's going to be the error? They say what's going to be the error is for us. That error can help us to improve our network. So when you get that
Okay.
error, what's going to do with the error? The only thing first, what you can do first, just try to send that error backwards and use that error again to update our link with.
Okay.
And so when you watch the calculation you are doing, I'm asking you guys, why is that when they find the total error or the error into this e hidden one here, I see they are they are summing two errors, one from the e output two and another one from e output one. They took some part from here, they took some part from here, and that gave us the error into this one. I'm asking why is it that? Can anyone tell me the reason why?
Okay. Can you go to the next slide? I want to use it to explain. Okay, it's like when you take the e output one, uh W11 is contributing to that error. That's why we are multiplying it to the output one. Then W12, though W12 and W11 are from the same node, but W11 is contributing to the error at output one, whilst W12 is also contributing to output two. I think that's why, though we are adding them, but they are multiplying different outputs. Hello?
Is it understandable? Like, do you guys understand? Is it
Sorry.
understandable?
The E output, yes, that's the error. Is it the error we found last time, like that means our last class? Is it the same error we use?
Please come again.
I said the
Well,
error with the E output error. That's the E basically meaning that's the error. Sorry, is it the one we found from the last class? That's the error we're trying to find from the last class from the weighted one and one. Is it that same error we're using here?
Sure, but it's like this one we are using two network altogether. This network is different from the one we used earlier.
Okay.
see, the last Wednesday class, we are not
Yes.
finding error. We are not finding error. We are only finding output.
Yes.
What we did the other time is going to give us an output. We call it feed forwarding. It will give us an output.
Yes.
But our output that we are having, we are comparing that output to something. There's something there you're just trying to you want the output to like to target or to rate. Maybe after the feed forwarding, after the feed forwarding we did, the output they give us an output of the network gave us an output of let's say 0.6. But what we really wanted was one. We wanted the network to give us an output of one.
Yes.
But I give us 0.6. So you can see we wanted one, but I gave us 0.6. 1 minus 0.6 meaning that will be the difference between the two outputs.
Yeah. Yes.
So what I'm just trying to say, so the difference between them, no, we are going to get an error, and that error is what we are dealing with today. So you can see that what's being displayed here is a is equal to t minus zero. A is equal to
Yeah.
t minus zero.
Yes.
Yeah. And the T is the one that the T is the one the T is the one we are the desired one. That's the one, like the value one, like the desired one we wanted. But
Okay.
the O is what our network give us, like the actual output. The our network give us O. The difference
Yes.
between them is an error, and that
Okay.
error we are not going to throw it away. We're not going to throw that error away. That error is very very important for us. We have to send that error back again to help us to improve our network. So what you're doing
Okay.
now, we're just trying to send the error backwards. We're just finding how we can send it backwards. So everything I'm seeing here is just finding the means to send it backwards. And well, that's why you're seeing something like this. So the error that we've gotten, this E error that we've gotten, how do we send it backwards? That we are saying we can send it backwards through by dividing it proportionally among the weight links. Because each node here is going to give you each node here is going to give us an error. And see that you can see this one have only two layers here, the input and the output layer. And the output layer have two nodes here, and each of the node will give us an error. Each of the
Okay.
nodes will give us a prediction, and that prediction there will be an error in it. And that error that they get from it, you just have to just check the link weight connecting to that. You have to just check the link weight. I'll check the link weight connecting to that node, and just divide the error among them. When I take the node here, the node here one here, you can see the link weight connecting to it is just W11 and W21. So this error here, E1, I just have to divide it proportionally among this one and this one. And what's proportionality? Proportionality is just have, if you want to find something proportional, we take the value here, like W11, divide it by the total lengths that's connecting to the node here. So W11 over W11 plus W21, something like this. W1 over W11 plus W21. That will give us a proportion of it. Proportion that will belong to this one. We will do something similar to for this one. W21 over W11 plus W21. So you're going to give us a proportion. Then you have to just multiply by the error. E1, E1. So if you should do that, we get a link, we get an error that's associated with the link weight here. We get another error here that's also associated with this link weight here. See? So if we can do it for each of the link weights here, then we have to just go back to the previous node again. This previous node again. You just have to just find the weights connecting to it. You can see it's this one. This time it's just this one and this one. Then we find the proportion of the error for this one and this one, just add it together. That'll give us the error into this node here. Give us the error into this node here. So that's what you are trying to do here. After propagating the error to this side here, and after propagating to this side here, you just add these two together, and that will give us the error for this one. And that was the calculation you're trying to do here. That was the calculation you're trying to do here. Is it okay?
So currently, like this formula now, we don't have the error yet. We're trying to find it.
Ransford, do you understand?
Sure.
You know, we still have it's like you don't understand what I'm saying. The, the errors, what
Uh,
this multiplication you're seeing, this multiplication you're seeing, this one here. You can see the printing
yes.
W11, W11.
Yeah.
This W11, this W11. There will be an error associated with it. Like an error will be linked to that weight. An error
Okay.
will be linked to that weight. This W12, you can see you have a W12 here.
Yes.
And that error will also be linked to it. And but
Yes.
since they are all coming from this node here, you can just add those errors together. When you add those
Okay.
errors
Okay.
together, that will give us the error for this node here. This one is an error for this link, just this link. This one also error for this link.
Yeah.
But this node also have an error. Also need an error. And that error is just the
Okay.
addition of the word of these two link weights. Of these two link weights. So let's try and see if you can take an example. This something here. What just one error? You can see you have three layers here. Three layers is here. And these three layers, the output layer is having two nodes. This one and this one. And with the first output node here, you can see the E signifies an error. You can see this E1 is having an error of 0.8. Having an error of 0.8. Then, since it's easier for us to find the error for the output node than to find the error for the
Output
hidden and the
hidden.
input. It's easier for us to find the error for the outputs, like the nodes in the output layer, than to find the errors for the nodes in the input and the hidden layer. So to get the error for the nodes in the hidden and the input layer, you just do backpropagation. So when you take the output layer here, E1 is equal to 0.8. So 0.8 here, for us to be able to just replicate or to just transfer some part of the error to this node here, what we can do is just have to find the proportion. When you take this node here, you can see the link going to it is this one and this one. I'm talking about this node here. So let's just go and find the error associated with the link coming from this node here. That's W11. So the error associated with W11. How do you find it? Or how do you calculate for it? You just have to take its proportion. W1, so you just have to take 2 over, it should become 2 over 2 plus
2 plus 1.
3. It's not 1, 2 over 2 plus 3. Why am I
Okay,
saying
you're
2 plus
taking that
3?
one. Okay. Yeah.
I'm
Because
saying 2 plus
there's
3 because
an output from 2 to that node you are looking
I'm
for.
saying, yeah, because you can see this error here, even though we are finding the error for this one here, you have to do it with respect to this node. This output is the one having an error. And the links connecting to this error is this W21 and W11. So proportionally, the value for this is supposed to be 2 over 2 plus this 3 times the 0.8. If we should do that, that would give us an error associated with this link weight. Then we do something similar to for this. Even though we don't need this link weight, we don't need it. We are just trying to do this for it. When you're done, you come and take this node here. You find the error that's linked to this weight here. So use the same idea, find the error that's linked to this weight here. Even though we don't need the other two, the link with W21 and W2, we don't need it. We're just trying to find it just for it to be there. The ones we really need is just this link weight and this link weight. And if you're able to get the error, you just have to just add it together, and that'll give us the error for this node here. So if you guys can just try and and if you understand it a better, what I can just tell you is that one of you should just tell me like like how do I find the link weight for this W11? Or what should be the formula? What should be my expression for the link weight for this W11? W11. W11. Let me try and type it and see if you can just all follow along. So what I'm just trying to say, so for me to get a value, the value of the error that's linked to this weight here, that's linked to this weight here. I said it will just become 2 over what? 2 over 3. That'll
Plus
just
2.
come that'll just come at 2 over 2 plus 3.
plus 3,
Okay, then times the error you are trying to get
0.8.
0.8. So that would be the link weight for this W11. For this W11. For the W11. W1. W11. That would be the link weight for W11. And then what I want, my final thing I really want is the error into this node
Please,
here.
I have a question.
Yeah, what's the question?
Okay, initially I thought after finding the when after doing that calculation 2 over 2 plus 3 times the 0.8, I thought that would be the answer for the error contributed by W11.
Yeah,
I
that's true.
didn't know is
So
this it will be the same as the link weight. I thought the link weight would be different from the error.
you said that's the you said well that's the error for what?
You say now you are saying that the link weight will be that's 2 over 2 plus 3 times 0.8. Initially, I thought that when you're looking for the error contributed by, let's say, the W11, we know that W11 and W21 contributed to the error, giving us 0.8. So to find the error associated with the W11, then you do it 2 over 2 plus 3 times 0.8. But now you are
Yeah,
saying that is the same as the link weight. I never knew it's the same as the link weight. That's why.
yeah, because W11 is a language, like W11 is a language. Like
Okay,
W11
okay.
itself is a language.
So here in this case, we call it
So that's the
the
proportion of
link
the
weight,
that's the
not
proportion of the there's a proportion of the error for this link weight.
okay, okay, okay.
So for me to get a proportion of the error for this one, the W21, so I have to, what can I do? For me to get the error, the proportion of the error for the W21, what can I do? So that's W21. The
Okay,
error
3
associated with it will become 3
over
over
3 plus 2
3 plus 2,
times 0.8.
0.8. Why are you saying 3? Someone may ask, why are you doing 3 plus 2? We are doing 3 plus 2 because when you check this link weight, it's going to this one. It's going to this output here. And this output node, the lens connecting to it is just this one and this one. So we just added the value for these two link weights on this side here. So that's the difference. 3 plus 2. Then multiply by the error. Then multiply by the error. So what to be the link weight for this one? The W12, the W12.
It will be 1 over 1 plus 4 times 0.5.
1 over
1
okay,
plus 4.
1 over 1 plus 4. Okay, so meaning you really understand what you're doing.
4
It's
times.
true. What you said is true. Okay. So if we cannot find the link weight associated with each of the link weights, then we are done. We can just find our error for the node. We also know that link weight is different from the node. The link weight or the link weight, they are different from the node. We can have an error for the link weight and can also have an error for the node. So now let's just try and see the value. So with this one, with the W12, we should just find for the error. Instead of just doing the writing the formula, let's just try and write the value. Let's just try and write the value. You just have to do a calculation,
Hello.
just write the value. Yes, hello.
Can we get the slides at
Yeah,
the
you
end
want to
of
speak?
each tutorial?
All right, I'll send the slide. So now let's since we know the formula, I don't know if you all know it, sir. Since you know the formula, let's just try and compute the value for W11. let's find compute the value for W11 and see. Try and compute and give me the answer.
Okay. Hmm. Let me see. So W11 first, right? 2
Yeah.
divided by 5 equals times 0.8. 0.32.
So 0.32.
Yeah.
Okay. 0.32. And let's find
Two one.
W12.
Okay, one two.
W12.
One
What's the value?
divided by 5 times 0.5. 0.1.
Yeah, 0.1. And go to the next one. W21.
So 3 divided by 5. 3 divided by 5 times 0.8. 0.48.
Is 0.48. And last one,
Then
W22.
4 divided by 5 times 0.5. 0.4.
0.4. So apart from Ransford, like, do you guys are you following me? Do you understand? So the three of you, like, you understand what you're doing? All right. So to find the error for the node here, to find the error for the node here, the only thing is that we have to combine the error of the link with W11 and W12. You know,
So we add
W11 is
them.
0, yeah, W11 is 0.32 and W12 is 0.1. So 0.32
0.32.
plus 0.1 give us 0.4. It's going to give us 0.4.
0.42.
0.42. So that's why
Yeah.
when you go to the next, I can see the row 0.42 here. The error for that node, the row 0.42. So similarly to, you can also find it for the error for this node here. You just add the error from W2
0.88.
0.4, then 0.48. So you're going to get 0.88 also here.
Sure.
That's why they see they had 0.88 there. 0.88. So that's the idea of how you can just transfer it from the error from the output node to from the output layer to the hidden layer. I don't know if it's understandable. So that's it. So this is how you go about it. And then since we already know the formula to propagate it backwards, we can also just convert it into a matrix notation form and convert it into a matrix notation form. Like what we did with the pick wedding. A matrix notation form, always what you are trying to the input or what you are trying to use to bring it to the network, it's always built on its own, like we're like a vector. You can see they've made the error as E1, E2. That's a vector on its own. Then the proportions are also being in matrix form. And surprisingly, I see that on this row here, these two proportion are going to the same node. They're going to the same node. You can just watch here. When you watch here, see the node here. This node here, the error come there. This node here, the link coming to them is W11 and W12. You can see I have W11 and W12. They're on the same row here. When it comes to the down here, you can see the link weights coming to this node 2 here is W21 and W22. So you see W21 and W22, they're also in the same row here. So the same idea of what we did last week, the same idea I'm just trying to use. I mean, you can change it from this hard way of calculating to this matrix notation form. This is basically just trying to show how you can do the matrix multiplication. With multiplication, you just have to multiply this one by this one plus this one by this one. Then it's going the same one. It's going on one row. Do the same thing for this. Multiply by this. Multiply by this. To be on the same row. So when you do that, that'll be the error into the hidden layer. You're able to do it. That'll be the error into the hidden layer. Even if you don't understand this one, just try and understand the idea that we can transfer error from the output layer to our input layer. Like can do backpropagation. What you're doing is called backpropagation. You're trying to vectorize the process. Because this one is just trying to give an idea. You're not going to do any hard calculation when I write the network. You just have to use a matrix to do everything. So you can see that the most important thing is the multiplication of the output errors. It's very important because if a link weight is contributing, it's having a very high value or a very high link weight, you can see they will get more of the errors. So the larger the weight, the more the output error is carried back to the hidden layer. The denominator is just a normalizing factor. We can ignore it to keep our matrix multiplication simple. So what you're seeing here, what they're just trying to say is that the denominator you're seeing here, you can ignore it. You can ignore it in the sense that you can see if W11, the value of W11 is greater than the value of W12, no matter what, no matter the calculation you're going to do, W11 will get more of the error, as compared to W12. No matter the calculation you do, W11 and will get more error as compared to W12. So the denominator, what the denominator is just trying to do, is just trying to keep them on the same scale. Just trying to keep on the same scale. But if you remove the denominator, nothing really is going to happen. It's still the network is still going to work. So what you can do here is that you just have to remove the denominator from the just keep just the numerator. So in a simple way, to do the backpropagation, we just take our errors from the output layer here and just take the link without connecting to the nodes we want. You can see here representing W11, W12 as the elements on the first row. So when you tell the diagram here, you can see the error coming to this node here is this W11 and W12. So that's when you saw those two elements or those two weights here on the same row. So W11 and W12. And see on the same row, W11, W12, because they are all going to one node. And that one is also going to a different node. If we were having like 3 nodes, there will be another row here, another row here for it. If there's also 4, there will be another row 2 there below. So this is how you can this is the idea how you can transfer the error from the output layer to our input or to our previous layer. But I use the same idea, just transfer the errors to the input layer. But when you watch this diagram very well, it's similar to our link quiz that we started with, like our fit forward that we did. If you can remember the weights we're dealing with, it looks similar to this one. But the only difference is that we have interchanged some stuff here. The previously this one was here. The element here was at this position, and this one was at this position. In the matrix form, we call it a transpose. We just transpose it. So that's what you're seeing. See, the error weight matrix is the transpose of our link weights. The transpose of our original link weights. So this is what you had for the error here. But this time, they just transpose it. They just transpose of our original linked list matrix. And if you don't understand transpose, what I'm just trying to say is that if you have an element like this, if you have a matrix like this, 1, 3, 2, 4, and you transpose it, it just becomes something like this: 1, 2, 3, 4. You see, the elements here, 1 and 3, will now become, to say, also on a row here. Now it will now become a column here, and this 2, 4, which was row here, just become a column here. So that's the idea of what that's the meaning of transpose. The same thing here. If you just transpose this matrix, 1, 4, 7 is a row here, it just become a column here. 2, 5, 8 is a row here, it becomes a column here. 3, 6, 9 is a row, it becomes a column here. For the transpose. Yeah. So it's in a simple notation form. To do backpropagation, you just have to take out the transpose or weight link of our original weight link weight. You have to take the matrix of our weight links and just transpose it, just multiply it by the output error. Because the output error, it won't be one to many. It will be many, so you can just save this in a column vector or in a vector form. And just multiply it by the weight link. Yeah. And just multiply it by the weight link here. So to see that what you're doing is true, let's just try and see. You say this how we can just do to do back error propagation. Let's just take the example we're working with. And you have to try and use our Jupyter notebook and work with it. So this is the weights, this the what we're working on. This the answer we have here. I don't know if anyone can take a screenshot here. And we just open our Jupyter notebook and also try and do something similar. Use the using the matrix and see if we can get an output like this. The output we are just trying to get is this one, 0.42 and 0.88.
I
So we
have
can
the
just take
screenshot.
screenshot of this screen. So I'll open my Jupyter notebook, or we can both open our Jupyter notebook and we start working on it. I'm now starting my Jupyter notebook, so it will take time.
Hello.
Yeah, I'm now starting my Jupyter notebook, so it will take time.
I think someone should take the screenshot. My phone is telling me screenshot cannot be saved.
Okay, for me, I'll have it at the background. So me, I'm just thinking about you guys,
Okay.
so they can just
The
follow it
screenshot
along.
for what? This one?
Yeah.
Okay, I've taken it.
Okay. So now let's see how our matrix will look like first. Let's see how our matrix will look like. What do you think with our matrix? What do you think with the matrix here?
Hello. Come again.
What will be the matrix, the link weight matrix for between the hidden layer and the output layer?
I think we have 2 by 2 matrix with for the weights against a vector, which is the output layers.
Okay, but what will be a link weight? Like yesterday, our last session. If we did something like we did something like converting this one, like this link we just seen, able to convert it to a matrix notation form. So what I'm just trying to say that this weight link that's between the hidden and the output layer. What will be the matrix? We want to write this in a matrix form. What will be the values? What will be the element in it? It to be a two by you know it to be a two by eight matrix, it's true. But what's the element in that matrix?
Okay, first one you have uh one we open a bracket, you have W1 in the same row, then you have W12, then you come and have
Okay, what
W.
you're doing it for the weight, like you're doing it for the error back propagation. I'm talking in terms of the feed forwarding. It will
of
become
the
W1. It's become W11, W21.
still I'm
Last week,
kind of confused.
when you're doing the fit forwarding last week, the last session we held,
Sure, sure.
I don't know if you remember, we were doing feed forwarding. Like we were able to convert the link with us between the hidden and the output layer. We were able to get it. We were able to represent it in a matrix form. Because the only thing that we did was just take it. We just take the link with us going to this node here. We take a link with us going to this node. You know, is this one,
Your cursor is not showing. Okay,
is this one, and this one, this one, and this one. That's going to this node. So these two will be on the same row. W11 and W21. We are our original wavelength. It's not the back one, the back one. Original to original one.
okay,
Because what they told us here is that, and see, they told us here is that we don't have to bother about the backpropagation error. The only thing you're supposed to just find our original wavelength here and just transpose it. That give us the wavelength for the backpropagation.
okay,
That's what I'm saying. Our main concern is about the market for the weights, the feed forwarding. When you would take this here, the weight going to it is this one and this one. When you take this one, the weight coming to it is this one and this one. So with this one, the weight coming to it is this and this one. They'll be on the same rule. So we have 2 and 3 will be on the same rule.
Okay, they'll
Then
be on
one,
the same row due to the arrows, right? Like W11, W11, W21.
yeah, because they are all going to this, because they are all going to this the same node here.
Oh, okay, okay.
And so the link is going to the same node here, also be on the same rule. So our matrix will be more like 2, it will become 2, 3 on one row, then 1, 4 on a different row. Do you guys agree? I don't
yes,
really. Alright. So now I'm going to display my let's just keep track of the answer that we put together. We need to get something like 0.42 and 0.88 as our final answer.
okay,
So what you're supposed to do, you just have to import our numpy, import numpy np. No, they were np just making it short for me. Instead of always writing a numpy, I'm just trying to make it
okay.
short as np. So in np
Abbreviation.
dot, yeah, abbreviation, the matrix, the matrix. Then I said the weight link is just 2, 1, is 2, 1, then 1, 4, then 1 and 4. That's the weight length. Let's say weight, my weight length. Then I have to find for my vector, my error vector, or the error vector. The error vector was 0.8, np matrix was 0.8 and 0.5.
Arrow.
So then I have coming np dot w weight length, then error vector. Can you guys see it?
Yes,
I think you can see it. That's nice. Right. So If I should run this, say I'm guessing. Say W is minus one okay. See, this no equal to what I was looking for. The reason is
Hmm.
because let me just try and come and just put transpose. 2 1. So I'm gonna bring this W1 2 1. So who can tell me the reason I'm getting this error here? I said we needed to get
Uh,
something like
I,
0.42.
I, I'm thinking that you with the np dot product function, the error vector should come first before the weight links.
Something like this.
Then
Something
the
like
weight
this.
links will come. Sure. No, not with the transpose. Or
Not very
or we
transpose.
have to transpose first.
This house comes first. This one has come first before because the
I'm thinking
rows
the transpose should be outside.
to outside.
Yeah, like because the transpose is like the is it's the transpose of all of them. That's what you're doing, right? Oh, sorry. The transpose is just for the W link.
Sure.
It's just
Okay,
for
okay.
it's for the waist length.
Oh,
2114. Did they transpose it? Did they transpose it?
Come again.
Did they transpose it?
Sure. Because
I
the
don't
value
think trans.
one one they are okay. In that case, let's use the first row, the second value one. Let's use three and see if it will transpose. Because since the values are the same one one, in case there is a transpose, you'll be able to detect because they are the same values. So I think we should use 2 comma 1 or 2 comma 3 to see whether
Use 2,3.
yes, so that we will be
2,3.
able to determine whether it's okay. Then we print the W links.
Why are you using 2,3?
You see, you were asking whether the output we got there was a transpose, and I'm saying that because we are having 2 1 and 1 4, we all know that with transpose the one in the first row will come and occupy the position of the one in the second row, and vice versa. But because they are all one one, it's hardly will you be able to detect whether there was a transpose. That's why I was suggesting whether
I think
we
the
can use.
transpose matrix. Let's not talk. The transpose matrix in I think NumPy is something like this. Two
You see,
two
we are
one.
still getting the same answers. So how will we be able to know whether there was a transpose? But if you're able to, if we change the 2 1 to 2 3, after that, we'll be able to know whether there was a transpose. Then we bring it back because
Two
since they
one
are
to
one
two
one,
three.
then
All right.
okay,
So it
this
means
means that
the
there was a
transpose is working.
transpose. Yes, so we
Yes,
can
okay, transpose.
send it back to one.
T. T is also giving us a transpose. Oh,
Sure, it should also give us. I think the T2 should give us all.
yeah, the T should give us. So NumPy dot np dot transpose is in our error vector. 2.1, 2.3. Are you doing the right thing?
Sure, it's
Two.
like hello.
Okay, it's 2, 3. It's supposed to it's 2, 3, then 1, 4. All right, 2, 3,
Sure,
and 1, 4. Oh, we don't have this thing.
but you are getting 3.1. When you use 2314, you get 3.1 and 2.8. Okay, I didn't use the transpose. Let me try using it and see.
All right, so I don't know why I'm getting an error. Like it's supposed to be 0.42 and 0.84. But what's 2 times 8? What's 2 times 8?
2 times 8
2.8 to give
is
us what?
2 times 0.8. I'm coming. Oh,
That's 0.16 now.
0.169.
No, not 9, 16.
16. Because if you should get a matrix, that if you should get a matrix like this. All right. Do you know the reason I get an error? No, with the previous one we saw, they were normalizing it. I don't know if you remember. They were normalizing it.
sure,
Like,
sure, sure. The last time we did.
yeah, they were normal like, but this time we've taken the denominator away from it. I don't know if you remember. So I did something like that. From the PowerPoint,
Sure, sure. We divided by some total.
yeah, the PowerPoint we're dividing by the total of the two.
Yes.
Yeah. So if you should have divided by the same thing, you can think you're going to get the same answer. By this time, we've taken away the denominator from it. That's why you're not getting the similar answer to it. Hmm.
Now, my question is, uh, why are we transpose? I thought we only do the transpose after getting. You only get the transpose of the matrix after multiplying it, or yeah, after multiplying it with the error. But here lies the case. We are transposing it before finding the dot with the error.
When you watch the formula very well, it said to get a error into the hidden layer, he said take the weight link matrix, our original weight link matrix, and transpose it and multiply it by the error vector.
Okay, okay, okay.
Yeah, that was the formula we had at the end of the like what we did.
We will surely need this slice.
Yeah, also, yeah, I'll send it to you. So you have to keep it in mind. We've taken away the normalizing factor from it. We've taken away the denominator from it. So that's when you're gonna get something similar to it. Right. So if you understand it up to this point, before you even continue, the most important, I think the next one will be how to find our slope. We find the slope for the we find the slope and use it to update our weight link. But I think before we even continue further for it, we just have to introduce ourselves to Python Django. As you all said that you already know how to code. I think everyone said they know how to code here. So since we already know how to code here, we won't even spend most of the time talking about the Django.
So we all said what?
Do you know how to code? Do you know how to write some programming language? Like,
Yeah, HTML, CSS for now.
but like programming language as in maybe Python or C sharp or something like that.
Okay, C plus, but not Python. I'm still learning Python.
Yeah. So you know be bothered much about it. You're not like a naive way.
Okay.
So what we are going to do now is we just have to set up our Python. You all having Anaconda. We install Anaconda.
Hello.
Yes.
We install Anaconda. So let's check if you have pip installed. Let's just go to your command prompt, just type enter pip and see if your what you're going to get. Just open your command prompt and enter pip. PIP.
So let's do what? Can you hear you?
Open your command prompt. I don't know if you're on Windows, but if you're on Windows, just open your command prompt and enter PIP.
VIP.
PIP. Pip. Pip.
Okay, PIP. Should I run it?
Yeah, when one goes, what's
Yes.
happening?
Enter.
So when I run it, it's just showing like a okay. I've clicked on enter.
You say you did what?
Some things came out like some writings. So I just clicked on enter.
The commands
Yeah,
that
the
you can
command.
run